graph of y equals f of x is shown in the figure above, on which of the following intervals are dy over dx greater than 0 and d squared y over dx squared less than 0?
Okay, let's analyze those two. So it says f prime is greater than 0, meaning it's positive. So if f prime is positive, the graph is physically doing what? It is going up. If it is positive, it's going up. So I'm going to say the graph is going up. And then it says f double prime is what? Negative or positive? Negative. So then when f double prime is negative, the original graph is going down, concave down. So let's kind of try to match these two conditions. So between A to, is that A? I think it is. Between A to B, it is going up, correct? But between A to B, is it concave up or down? It is up, okay? Now let's look at B to C. From B to C, it is positive, correct? And B to C, is it concave down? When I draw this, am I caving down in the end? Yes, I am. So we know this has to be the answer. But let's talk about CD. CD, my slope is going down. And that's not what I want. So we know for this one, it has to be between B to C, which is second one. Okay, let's move on to number 6. For number 6, Bailey, let's read.
The graph of a twice differentiable function f is shown in the figure above. Which of the following is true?
Okay, so if you notice the answer choices, the x value that we're looking at is 1. So I'm going to write out f of 1. Also write out f prime of 1 and f double prime of 1. And let's write what we can about it. First of all, what is the point at x equals 1? What's the y value? 0. Very good. And at this point, is my slope going up or down? It is positive. And then this one is, so I'm going to say the graph is going up. This graph, is this cave up or cave down? Cave down, so I'm going to say cave down. Because it is cave down, that means my double prime is negative. So if I give you any positive number, any negative number, and some 0, to order this, this is going to come, this will be the biggest. And that being the biggest is going to be option not A, option not C, and not E. So how would I order this? Positive number, negative number, and a 0. B or D? D, very good. 11 is going to involve a little bit more writing, so bear with me. Okay, for number 11, Jack, let's read the first part and part A, please.
Solutions to the differential equation dy over dx equals xy cubed also satisfy
The second derivative.
the second derivative equals 3 cubed 1 plus 3x squared y squared. Let y equals f of x be a particular solution to the differential equation dy over dx equals, with f of 1 equals 2.
And part A?
Write an equation for the line tangent to the graph of y equals f of x at x equals 1.
Thank you. So they gave us a point at f of 1 is 2, so that means 1 comma 2. So that's going to be my x1 and y1 piece. So to write the tangent line, not only do I need a point, I also need a what? Slope. Didn't they already give us dy over dx? Yeah? So we know our dy over dx is my slope, so I can plug in the 1 and the 2. So I get 1 times 2 to the power of 3, and that's going to give us 8. So our equation is y minus the y1, which is 2, is equal to my m, 8. And x minus the x1 is our 1. All right, for the part B, let's see. Holland, will you read part B?
Use the tangent line equation from part A to approximate f of 1.1
That was a lot of wording, right? Okay, let's make it very simple. It's basically saying plug in 1.1 into your new equation. So we have y is equal to, I think I'm gonna go ahead and say, ooh, I should put 8 over here. 8 times 1.1 minus 1. And are y'all okay if I just go ahead and say plus 2 at the end? It's kind of like adding 2 on both sides. Yeah? Let's actually compute this. That's going to give us 8 times 0.1 plus 2. So we have 2.8. So our point is 1.1 comma 2.8. Now the explaining part. We have to actually plug something in for us to figure out the explaining part. Let's plug in 1.1 into the original equation with 2.8. And you don't really have to do a lot of math on this one. You're just plugging it in and figuring out if it's positive or negative. So my y value is 2.8. We're going to this one right here. So we have 2.8 actually, yep, 2.8 cubed times 1 plus 3 times my x is 1.1 all squared times 2.8 all squared. Now here's the bottom line. Are they all positive numbers or are they all negative numbers? If they're all positive numbers and I'm adding it and multiplying it, am I going to end up with a positive or a negative? So I'm going to say this positive. So when f double prime is positive, what kind of concavity do I have? Concave up. So when I have concave up and I have a tangent line, and I'm going to show you visually, because I'm a visual learner, I don't know about you. So at 1.1, I got 2.8, but the actual tangent on the circle is right above. So that means my value is less than. So let's put on here, because it is concave up, the approximation of f of 1 is less than or more than. This is less than the actual.